Hi guys, so today is the day 8 of the September LeetCoding Challenge 2021, and on this day 8 we have been given to solve this problem, and this problem is shifting letters. So in this problem, like, we have been given a string s, and we have also been given an array, integer array, shifts, and both of them are of same length, and this string s contains only lowercase English letters, and there is one operation shift, and it will be performed on a letter. So on whatever letter it is performed, it transforms that letter into the next letter that is following it. So basically, like, suppose it is performed on this letter A, then we will get B. If we will perform it on B, then we will get C. Similarly, if it is performed on T, then we will get U, because U comes after T. And like, what if it is performed on the last alphabet? So basically, if we will perform it on the last alphabet, then it will, like, give us the first alphabet. So basically, if it is performed on the Z, then it will give us A. So this is the shift operation, and like, in this array shift, we have been given the number of shifts we need to perform on the first I plus 1 letter. So if we consider a zero based indexing, so for this I equal to 0, so this I equal to 0 contains 3, so these 3 shifts will be performed on, since it is 0, the 0th index, so this 3 will be performed on first 1 characters. Similarly, it will be performed on this 5 shifts will be performed on first 2 characters, and similarly this 9 shifts will be performed on these 3 letters. So we need to, like, do all the shifts, and then we need to return the answer we will be getting. Similarly here, like, 1 shift will be performed on here, and 2 shifts will be performed on both the first characters, and 3 shifts will be performed on these all the 3 characters. So this is the problem. So we can take a look to the constraint. So the length of the string s is up to 10 to the power 5, and s contains only of the lowercase English letters, so it was evident from the problem statement. And yeah, this condition is also mentioned in the description, that both the arrays are of same length, and the shifts that are present inside the shifts array may range up to 10 to the power 9. So we can see that the total number of shifts after summing may exceed the like range of integer integer data type. So we can use a long data type for, like, calculating the total shifts for each index, or we may do something different to to avoid overflow. So, like, I'll be doing one thing. So that is, like, after 26 shifts, the character will become equal to itself. So we can keep taking mod with 26, and whatever quantity we'll be getting after taking mod, after performing any addition or subtraction, then that shift will give the same effect as the previous shift. So I'll be keep taking mod with 26, and still use the integer data type, so that I don't like overflow the integer data type maximum range. So this is the, like, problem statement. We can take a look how we can do this problem. So first of all, like, I will make an array, and basically this is an array, and so this array will contain the number of shifts we need to perform on each character. So in the, like, brute force way, we can do what? We can, like, add 3 to the first index, then we can add 5 to both these index, so it will become 5, and it will become 3 plus 5, that will be 8, and then we can add 9 to all these 3 elements. So all these three elements will be added with 9, and whatever we will be getting, so we can keep it doing for the end first, all the end indices, and whatever the sum we will get after adding all these elements, that will be the number of shifts we need to perform on each character. But, like, since at every step we are adding I plus 1 elements, and this I plus 1 can be in the worst case will be n, like n additions, and they are will performing n additions. So the time complexity is order n squared. So like we won't be able to pass all the test cases with such time complexity, since it is of like the length of the string s is up to 10 power 5. So we'll be doing some optimized approach to do this. So like there is one way of doing such type of operations in which like we are adding a number to a subarray of an array. So like suppose we are asked to add x from this part to this part. So basically we will be adding x to all these parts, and suppose we are asked to add y from this part to this part, and similarly some number z from this part to this part, any part, like any subarray of this array. And in the end, like we are like asked to return the total sum present in the final array. So like this thing can be done in a very optimal way. Like there is one way to do this in order n time complexity. So basically it is order n plus q, where n is the size of the array and q is the number of such additions performed. So in our problem it will solve this problem in order n. So let us see how we do this. So basically if we are asked to add x from L to R indices, then we will do what? We will add x at index I, L, and we will subtract x at index R plus 1. So basically we will subtract x from the index that is just after the last index. Similarly, if we are asked to add y from this cell to this cell, then we will add y here and subtract minus y here. And suppose we are asked to add certain number from some index to last index. So basically we will be doing plus z here. Suppose we are asked to add z from this to last index. So since there is no element to the right of this last index, so we won't be subtracting anything. And in the end, after performing all these operations, we can take a prefix sum, and whatever element we will whatever array we will get after taking the prefix sum, that array is the resultant array after performing all the operations. So in this case, like the resultant array will be x, it will become x, it will become x plus y, it will become x plus y plus z, and here it was minus x, so it will only remain y plus z. So this y plus z will be also here, and it is minus y, so the last value will be only z. So this was the like required sum, total sum in this case. So we'll be doing similar thing here, and so let us implement this so we can get rid of this diagram. So this is the like implementation. So we can start by first storing the size of the array, and we are saying it n. Now what we need to do, we need to like make a array which will contain the total shifts. So I will be using integer data type, and I'll be making sure I take mod with 26 after every operation to avoid overflow. So it will have size n, and I will initialize it with 0. Now I will iterate from I equal to 0 to I less than n, I plus plus, and for every I, I'll be doing first. So basically the sum is done from index I equal to 0 to index I equal to I, right? So we will first add that shifts to the first element, first for the element present at the 0th index of the total shifts, and we will check whether this I plus 1 is less than n or not. So like if it is not less than n, then we won't do anything, because that is the case when we are adding elements up to the last of the array. So if it is the case, then we will do what? We will just subtract the shifts from I plus 1. And after doing this, first we need to ensure that we are taking mod with 26 after every step. Otherwise we may like exceed the maximum range of the integer data type. Similarly, we need to do this for this operation also. So here we were doing operation on the I plus 1 index element. So we will be taking mod with 26 with here this element. And after performing all this, we can now take the prefix sum of this total shifts array. So this total shifts I can be added with I minus 1. And after every step, we need to ensure that we are doing this. So like there is one thing that in C++, like if you are taking mod of some negative element, then it will return the answer in negative. But we are like, this may cause problem because like we want to increment, like suppose we want to find the final character by adding some quantity, and if it will give us negative, then we may like kind of get the wrong character. So I will ensure that if this total shifts of I is negative, then I will add 26 to it to get the positive form of that resultant value. And after I have got that, now I will constructing the answer string. For constructing that, we can take a string called answer, and yeah, we need to like first calculate the next character that we will be getting. So this will be equal to si plus total shifts for that character. So this will like, this is the value after typecasting which into char we will get the character at that position. So first we need to ensure that this value is less than the integer equivalent for z. So if it is not that, basically it is like starting from the start. So basically after z it will start from a. So to get that value, like I will subtract 26. So now it will give us the correct integer equivalent for that character, and now I can typecast that quantity to char to get the alphabet at that position. And now after returning that, we are like good to go. So we may do time complexity analysis. So we are, for like n iterations, we are doing this order 1 operations. So it is basically order n step. This whole thing is order n step, and this is also an order n, and it is also an order n. So overall time complexity is order n, and space complexity is also order n because we are using this vector total shifts. So we may try to run it on this sample test cases. So we are getting wrong answer. Let me check what has gone wrong. So here like okay, the condition should be greater than z. So obviously, like if it is exceeding the integer equivalent of z, then we need to subtract 26 from it. Yeah. So it was, I have written just opposite condition, so that's why. So we may try it again, and now we are getting the correct answer. So we may submit it now. So yeah, like we have got accepted. So thank you guys. See you tomorrow with a new problem. Obviously day 9. And until then, keep lead coding.